collect your thoughts. Indeed, before we move on to the next section, you might fancy a break now. Okay, part 2, the metric tensor. We're going to consider a field. We could consider any field, a magnetic field, an electric field, a temperature field. I'm going to consider one of the most basic fields of all, a field with grass where the cows graze. Here is my field.
Anything else. Alright, go on.
And it's going to be a very bumpy field.
But if we do it any
there
other
are
way, it'd be
hills
negative, negative.
all over
No,
my
no, no,
field.
negative, negative here.
And here am I,
Negative.
standing on one of the hills.
Always.
And the
Here
value
American.
of the field is going to be the height above sea level. We usually give fields the value phi. And everywhere
I
you
got to one
agree
bit
in
while I was
my
watching
field,
this, and I was like, it doesn't
there
really
will
matter,
be a height above
because
sea
you're
level
going to
that
need
I
me to
can
do
measure,
some
and
shit
that
on the
height
stone
will
mill field.
constantly change because my field is a very bumpy field. Now, how do I know where I am? Well, I can impose a set of coordinates. Here's my x coordinate, here's my y coordinate, and I am then at that position on the x coordinate, and that position on the y coordinate. It's a bit like a map reference. So I uniquely define my
They don't
position,
actually look like
and
that.
for
They
every
do, but
position
they
I
don't.
take, I can find a value of phi, which is essentially
There's
the
all
height
5 of them in
above
one
sea
shot.
level
Here's
of
the
my
other ones
position
in Sunset. I was
in the
drunk when I
field.
did that night.
The question I
Comparatively.
now want to ask is, how does that height change if I move a little bit? And you should immediately respond that it depends
How did it move?
on which direction I move. The reason for that is, let's suppose that part of the field consists
Interesting.
of a ridge. Now, a ridge is something where the slope goes down on one side
You're gonna
and
get
down
up any other time.
on the other side.
You're gonna. I don't.
But along the
when
top,
it comes
it's
time
flat.
to some asshole named Salty
So if
riding
I'm
your ass, and you
standing-
come to me. You come to me.
on the top of the ridge, and I move, let's say this is the x
Look at
direction.
the lines. Look
If
at
I
this.
move in the x direction, I go down the ridge quite substantially. But if I go in the y direction, let's say that's the y
Be
direction,
the general later.
I'm just
If
walking
he
along the
walks
top of the ridge,
down
and that's
here,
flat.
To me.
So direction
So not only a time
of
that he had to
movement is
walk
important.
down
In the
the
x
ridge.
direction, I would drop considerably. In the y direction, I stay on level ground.
Where, get it off.
Now, how can I tell by how much the height will vary as I move along? Well, let's
Good question.
consider a gradient. Here is a gradient which I'm going to call a
The 300
1 in
IQ
10 gradient.
comprehensive skid
What that
steer
means
report.
is that for every 10 meters that I walk along,
Scout house.
I will drop 1 meter. So if I start here and I walk
Their
10
resume.
meters, by
I
the
did
time I get
this.
to the end,
They know me.
I have not only
just
walked
got
10
done
meters
training
along,
that kid.
I have dropped 1 meter down. And the way you would describe that mathematically is you would say that the change in height
Business.
as I walk along is equal to the gradient, which we express as d phi by dx, the rate of change of height
Mario
with distance. That's
playing the
what 1
game,
in
pulling
10
the rabbit
is.
out of the hat.
The rate of change of
Trying
height
to
with
get
distance
in my marshmallow
multiplied
treasure
by the
chest,
distance
y'all.
you actually
I'll slam that
walk,
bastard.
dx. Let's just try that for a moment. The change in height will equal the gradient. Well, I told you what the gradient is. It's 1 in 10. And let's say I walk
You want some
5
more?
meters.
You want some more?
So that the distance dx is 5 meters. That means that d phi will equal 5 over 10, which of course is a half a meter. So what we've just calculated is that if you walk 5 meters along a 1 in 10 gradient, your height changes by half a meter. But this is the
Did
general
the
form.
O5
You change in
give you
height,
clearance
change
or-
in the value of field is equal to the gradient multiplied by the distance you travel. Now clearly in my field I'm not going to have clear gradients like this because it's a very bumpy and irregular field.
Chain, hear that thing
But
snap.
over a very, very small distance, which is why I've put dx and d phi, that will be true. But as I said, direction
Am I clear
matters.
on that, man?
So
Black
consequently,
body, dark
one would have
love,
to
fuck.
say that the change of height,
Cosmic background.
if you were travelling in the x
We're good
direction,
here.
is equal to the gradient in the x direction
How much dark
multiplied
matter?
the
By one?
distance multiplied by the distance you walk in the x direction. Or you could also also say that the
You
change
might
in
not have
height
been. I know what
in
you
the
were in
y
the I
direction
saw it out loud.
is equal to the gradient in the y direction multiplied by the distance you walk in the y direction, which is fine. And these two gradients will not, of course, be
Figured
the
out
same.
later.
If we were on the ridge, this would be a very steep gradient in the x direction, but there would be a level gradient in the y direction. Of course, I may not want to walk in just the x or the y direction. Let's suppose that instead of walking in x or y direction,
Make
I
it
want to
dangerous,
simply
Aaron.
walk in that direction, just to be awkward. Well, of course, that is
What's that mean?
that
Alright.
is simply
Now, I'm
a
doing your math
combination
right
of
now.
walking in the y direction.
How I do that is I do this
and
like this,
walking in
and then
the
all of a sudden the
X
causal limit slams,
direction.
and I'm just looking at you like a board.
And in fact,
Inside here.
we can regard these as vectors, and in my video on the manipulation of vectors, I showed that when you want to add vectors together,
If you
do it
want the
by a
rotational
tip-to-tail
force of the saw, you
process.
go look at the saw.
So that in fact
And
you
you
take
couldn't
these two
handle one of
vectors,
those math
dy
problems
and
because
dx,
you had to
and
wait
put
for
them
some math
tip-to-tail.
teacher
It
to
doesn't
go
matter
out
which
there
way you
and
do
give it
it.
to
So
you.
let's take dx.
Then you take it.
It's like that.
This is
Then
it.
dy goes the tip
This is the
of the
pressure,
x vector
in your
matches
ass
the tail of
for
the
mine,
y vector.
right
So
in
this
there.
is dx.
and it'll be Hubble
This
45.
is dy, and then the resultant is the tail of the first and the tip of the last. So that becomes the resultant vector, which we'll call ds.
Wait for the
And we
next
can
one.
use Pythagoras to work out what ds is. Of course, ds squared is equal to dx squared.
You were having a
plus
normal day. It
dy
was
squared.
neutral.
That, of course,
And then
is
the
very
shit you
simple.
wanted to buy into just smashed. See, I
If
don't
you
know
want to
whether
add
you're
the
X
vectors
or
together,
one
that gives you,
or any
this
of
is
those
the
things yet.
magnitude, but for
Well, what I do
purposes
know
of adding
happened
the
is
vectors
something
together,
was
we simply
normal,
say that ds,
And then bang,
the
Hubble
line
45.
above it to indicate
Braggart
that it's a
theory.
vector, is equal to
It
dx
happened right in that box.
plus
Saw it.
dy.
And that was this little
Or,
box.
if we want to
Well,
know
if I
what
wanted
the
to, I could've
change
called
in
it that,
height
but-
is, we can say that the change in height
That's why those
as
aren't
we
really.
go along the path
They're
S
equal.
is equal
This
to
is
the
plus day
change in
2.
height as we go along the path X plus the change in height as we go along the path
Glypho
Y.
something. Somebody's broken
But
standard
these two
model. This is a
terms here,
3 by
dx,
perfect square and
d
3
phi
by
x
3
and
is
d
all
phi
this is.
y,
So perfect
we
square means
calculated up
I
here.
got the team running over here in the
That's what these two
schematics of
terms
the
say. So I'm
MOS
going to
chip.
substitute
For the
these
carpenter,
values
the mason, the
into
mathematician, the
this
heat vex
formula
guy,
here.
the dude who summons
And that
lambda,
will
the
give
devil,
me
whatever I
that
need
d
him.
phi s is equal to, now for d phi x, I'm going to replace that by the gradient times the distance. And here, I'm going to replace this by the gradient,
Mike,
but this time in the
come pay
y
your bills
direction
with your own money.
times the distance
You
in
got
the
it.
y
Why is he mad at
direction.
you? Oh,
And
you just
to be
running
absolutely
and
proper about all of this, what I should actually write
find out.
is I'm going to give these gradient terms curly d's.
You're doing things good.
And the reason I'm
Name
going
will
to
be
do that is
legend,
because
son. If
that's
not,
what's
it'll
called
be leisure.
a partial derivative. It simply indicates that although this is the derivative with respect to x, there are other derivatives. In this case, a derivative in respect to
You
y.
are
It's not the
many.
only derivative. So it's called a partial derivative, and it's indicated as a partial derivative by virtue of having a curly d. Now I want to pause for a while I do a nomenclature change, and I promise you it won't hurt. Up to now, I have
say
been
that.
using the coordinates
It'll be okay.
x
Skid
and
steer.
y.
It'll be fine. We'll get
I
through
am
this
now
together.
going to change them.
break
Wherever
on
I have
Monday.
used
And I'll be
x
sitting there on
before,
Monday.
I'm going to call that x.
Well, this
y.
certainly sucks.
And wherever I have
bunch.
used y before,
I was
I'm
like,
going to call
maybe,
that
but maybe I
x2.
should have done.
Why do I do that? Well,
Next time.
for 3 dimensions in space,
Still
we
good.
typically use x,
Believe me,
y,
the boss
and
ain't coming
z.
down here. We're
As our
still way
coordinates.
within inside the amp
Suppose I
limits for what this
needed
thing will
another
do.
coordinate. What letter am I going to use? There isn't one after Z. I could, of course, find another spare letter, but letters of the alphabet tend to be
It'll be
used
good.
for different purposes in physics, and it can become very confusing. Whereas if I relabel these x1, x2, and x3,
Now you do what I
if
tell you
I
in that
need
form.
another coordinate, it's a piece of cake. It's x4.
Right?
Indeed,
right?
I can even
right.
have an x0.
Oh, that's the
Which
next
I will
kid.
actually
We don't know that
use
next
for a
kid yet.
time
Patient 0.
coordinate. But if I need further dimensions of space, I can have x4, x5, x6, and so on.
Try to get
There's
in
no
here,
limit.
steal our marshmallows.
So,
We're not gonna have none of
firstly,
it, boy.
changing the coordinates
call me
into
boy.
this system
Yeah.
means I've got an unlimited number of coordinates if I need them, or dimensions of space.
Weird, no matter
And
how
secondly, it releases
They want
the
you to do it.
Y system.
Oh, cut
which
it
I'm
on
going
the
to use
table,
for a
boy.
different
Come
purpose
get.
a bit later on. So now I'm going to rewrite this equation here.
Oh, I thought you
In
were
my
going
new
with something else.
coordinates.
Yeah, they'd want you
Simply
to, just like I
replacing
do. I
x
mean,
by x1 and y by x2. They're exactly the same. I've just called them by different names. So if I do that, I will get the dphi, which is the overall change in height as far as my field is concerned,
right.
is going to be equal to the gradient, which is dphi by
That's
dx,
very
and now that's
technical.
dx1, times the distance I move, dx1, plus the gradient in the y direction, which is now the dx2 direction, times the distance I move in the x2 direction. And of course I could add further terms, x3, x4, x5, as many as I need. I'm only going to work in 2 dimensions to keep it simple.
Bunch of staff dictionary of terms,
And
marshmallows.
I think you'll see that this equation here
That
can
was a
be
good one.
simplified by saying that dphi is equal to the sum over n of
Got time?
the gradient dphi by dphi by dxn multiplied by dxn. When n is 1, you get that term there. When n is 2, you get this term
You
here.
don't have a rookie.
And the sum term
Not a
means
real
you just
rookie.
add them together.
Never had one.
So this is a very
Get one.
handy way of summarizing the change in the value of field according to all of these values. And you'll notice that n is the summation term. You have to do
big
this for all values of n. Here,
Where's
I'm only
big
having 2
estimation?
dimensions.
Start
But
over.
however many
What
dimensions
do
you
mean
have,
start over? It's
you
like
need
you
that
thought your
number of
book was good.
terms. And I'm going to call that equation number, I hope you can see that, let's just write that again, equation number 1. And I'll put a box around it so that when we
You
refer to
probably
it later,
wasn't wrong.
you'll be able to spot it. Now here comes the general problem with
Slightly
relativity,
non-derivative.
be it special
Like, well, the
relativity
block is the
or general
derivative over
relativity.
time space, man.
Any rules
We gotta
that you
put
come up
in
with must
a
be
lot of physics
independent of
before
the
the
frame of reference that you're using to make the observation. In my videos on
complicated
special
conjugative.
relativity, which I will refer to during the course of this presentation, we showed that different observers measure different distances and different
Complex
times
conjugative.
depending on their
Complicated
relative
conjugative.
velocity. That was called length contraction and time dilation. So if you want to have something that is going to be universally true, you have to make sure that it is true in all reference
Make
frames.
sure that fucker playing the game.
So when I
tight.
took my field,
Everybody
where I was
hates it.
standing on the hills,
Salty
and I
driver
put
looking
myself at
astronaut
position
motherfucker.
P, I set a coordinate system which I call the XY coordinate system, but subsequently renamed X1, X2.
Test for it.
And I
Road
said
sobriety
that
or in the mill every day.
was my
It's like you
map
can't argue with the
reference,
boss. Now you
X1
know he's a
and
good
X2
dude.
to
Had
find
shit
my
less to
position.
do with him fucking
But
being
somebody
in his
else could come
operation
along
and you
and
throwing
create
everything else
another
on.
set of coordinates,
I'm making
which
it
we
real
will
simple
call
for you. In
Y1
this swamp out here,
and
that's
Y2.
how this goes down.
And now P, of course I haven't changed my position, I'm still standing on the hill at position P, but as far as the Y frame of reference is concerned, the coordinates are quite
It gets to a
different.
point when you don't want to
Y1
leave the
and
hillside
Y2
because I
are
don't.
quite
Some don't
different
want to
from X1
charge
and
Carl
X2.
Sagan for it.
Even though I'm at
There's
the
a
same
gauntlet of
place.
mathematicians and STEM
And you'll
players
notice
out
that
there
if I
that you have
want
to
to
have lined up
express
on the chessboard.
Y1
Otherwise, they're
in
going to come at you.
terms of X coordinates,
you gotta have the STEM
I have
team
to
in there for
express
that
it both in
chessboard.
terms of an X1 coordinate and an X2 coordinate.
That's the cube, and then I'm
In
going to
other
blow
words,
it
the
up. Because it's
Y1
not going to work
position
from here. I noticed it out here.
for my
Yeah, so now I
point
got to
P
come down here and
is
scale
actually
it.
made up of an X1 and an X2.
Cosmic radiation
So the
background
question
doesn't do
then
no
that
good
we
here.
have to come up with is if
That
we
neutrino
know,
code
if
for
I
what
know
you have to factor inside here.
all
It just
the gradients,
if every cube
which
then
remember
is a
we described
Fermilab.
as d phi by
It's
dxn, in the X frame of reference, how can we find all the gradients in the y frame of reference, and more to the point, how can we relate the two?